an even power. Now we have an odd power. So the recipe for the odd power is different. So when we have if we go back, when we have an even power, we need to get that square, so we could use our double angle formula. Here we need to get the square, but not for the double angle formula. What do we use here? We end up using our square identity. Your square identity is sine squared plus cos squared is equal to 1. Alright, so how do we get that square identity? Because definitely this is not a square. So if you remember from your N5, what do we do to an odd power? Step number 1. We split the odd power. So that will be sine to the power 4 times sine. Okay. So now we have 4 here. From an even power we can get our square, because any even number can be divided by 2. Right. So we got sine squared all squared. Right, so we're using the exponent law. 2 times 2 will give you 4. Now we have our square. Okay. We have our square, so we can use our square identity. Sine squared, we need to use our square identity. Square identity, sine squared plus cos squared is equal to 1, but this is not sine squared plus cos squared. It's just sine squared. So you need to go to your square identity, manipulate that formula and replace sine squared. Simple, you all know what sine squared can be replaced with. What will it be? It's going to be 1 minus cos squared. Now remember, it's all squared. Sorry, that's x over 3. Now, you can use your u-substitution at this stage, or you can square it out first, but you have to square it out anyway, whether you use your u-substitution now or in the next step. Let's square it out first. If we square this, we got 2 terms, so that's 1 squared, which is 1. Your middle term will be 1 times minus cos squared times 2, which is minus 2 cos squared of x over 3. And the last term will be negative squared, which is positive cos to the power 4 of x over 3 times, you got your sine x over 3 dx. Alright, so now we have common terms here of cos within the brackets. What is not common here is the odd one out is only sine. Can you see that?
Yes.
So the fact is the derivative of cos is minus sine. So we are dealing with exact derivatives. So here we are dealing with type A, because it's multiplication here. Can you see that?
Yes.
So we are dealing with type A again, which is f of x to the power n times f prime x. So what do? We always let u equal to f of x. In this case, what is f of x? F of x has to be cos. So you're going to let u equal to cos of x over 3. So therefore, du dx, the derivative of cos is minus sine of x over 3 times the derivative of x over 3, which is 1 over 3. So you make dx the subject of the formula. So you cross multiply, you divide that. So dx will equal to du all divided by minus 1 over 3 sine of x over 3. So now let's substitute. Right, so wherever I see cos, I'm replacing it with, wherever I see cos, with u. So there's a cos here. So there's my u, but remember it's cos squared, so it's u squared. There's another cos there, but it's cos to the power 4, so it's u to the power 4. So here my dx also is du all over minus 1 over 3 sine x over 3. So you can see type A, the exact derivative of f prime x must always cancel. So sine and sine will cancel. So now let's write down what remains. So be careful, this is 1 divided by minus 1 over 3. If I take my constant and write it in front, what do I write down here? Minus 3. So that's just 1 minus 2u squared plus u to the power 4 du. So now, from here it's just straightforward. You integrate. With respect to u, integrate 1, that will be u, integrate 2u squared, that will be 2u, 2 plus 1, that will be 3 over 3. Integrate u to the power 4, that will be 5 over 5 plus c, and don't forget to substitute back. What was u? U was cos. So that's minus 2 over 3 cos cubed x over 3, and that is plus 1 over 5. That's cos to the power 5 of x over 3 plus c. Right, again, this is just a recipe also. So you need to follow the steps here. What's different? This is an odd power. Odd power, square identity involved here. When it's an even power, it's a double angle formula. Right, so you have a problem here. You have a negative exponent. You cannot apply any identities with your negative exponent. You need to make it positive. So, again, all you have to do is take cos to the top. So at the same time, this fraction, constant, always write it in front. So there's your 2 over 3 there. Take cos to the top, that will be cos to the power 5. Alright. This 3 does not go to the top. The 3 is not attached to cos. It's 3 multiplied by cos. So multiplication, you move it to the left. Alright. So now it's the recipe to follow. Step 1, split the odd power. So that will be cos to the power 4 times cos. What do we do now? We need to get that square so we can apply our square identity. So that will be cos squared all squared. So now that we have cos squared, you go to your identity, sine squared plus cos squared is equal to 1. But this is not sine squared plus cos squared, it is just cos squared. So how can we replace cos squared? This will be 1 minus sine squared. Right, so we are at this stage here. This stage here. Can you see that? Here you had 1 minus cos squared. There you have 1 minus sine squared. So you can square the whole thing first, or if you want to use your u-substitution, it's up to you. What happens if you use your u-substitution here? Let's see what happens. So at this stage, you know that the derivative of sine is cos, so it is type A. So if you choose to use your substitution at this stage, let's see what happens. You let u equal to sine, then the derivative du dx, the derivative of sine will be cos of x over 4 times the derivative of x over 4, which is 1 over 4. So then dx is going to equal to du all divided by 1 over 4 cos of x over 4. Alright, so now what do we have here? We got 2 over 3. So then I got 1 minus, I got my square there. Right, so now at this stage I am substituting, I am replacing sine with u. So there's my u. Here's my u there. What else am I replacing? I'm replacing dx, which is du divided by 1 over 4 cos of x over 4. So now you can see your exact derivative will cancel. So now be careful. You got 2 over 3, but this is divided by 1 over 4. So it's going to be 2 over 3 multiplied by what? 4 over 1. And we are left with just 1 minus u squared all squared du. So now we have to square it. You follow there? I just chose to square first, u substitution. Second, so I'm switching it around now. I'm using u substitution first, but you can see, no matter what I do, I still have to square this out. So now, here we got 4 times 2, which is 8 over 3. We square this, 1 squared is 1, minus u squared times 2 is minus 2u squared, and negative u squared all squared will be plus u to the power 4. So you come to the same thing. You can see that. You should have that in your book now. So now all we do is we integrate and substitute. So you integrate 1, that will be u integrate 2u squared, that's 2u to the power 3 over 3. Integrate u to the power 4, that will be 5 over 5 plus c. Substitute back. What was u? U was sine, so that is sine of x over 4. Minus 2 over 3 sine cubed of x over 4 plus 1 over 5 sine to the power 5 of x over 4. And you're done.
Started already? No, I haven't.
Now, do you remember what did we do? Now you are multiplying sine times cos. What you do is you check the exponents. Okay. So the rule is to split the odd power. Okay. But now in this case, both powers are odd. Can you see that? So if it was a even and an odd, then the instruction is clear. You split the odd power. But now when you have both odd powers, so we follow split the odd power. However, if both powers are odd and difference, when I say odd and different, I mean like what we have here, 11 and 3, not 11 and 11 or 3 and 3. That's a different technique altogether. Right, so we split the odd power. However, if both powers are odd and difference, you split the smaller odd power. Alright, you need to remember that. Right, so we got sine to the power 11. This is the smaller odd power, so we split it up. That will be cos squared times cos. So what did we do after we split the odd power? If you go back to this example, we're following the recipe now. We split the odd power, then we needed to use our square identity, but there was no square here, so we had to rewrite it as a square. But do we need to rewrite anything? We don't, we already have our square here. Can you see that? We have cos squared. So all we do is use our square identity. So cos squared can be written as 1 minus sine squared. Now, what do you do after this? So what we have here now is type A, but we just need to neaten it up. Write it down properly. But it is type A because these are common terms here. Can you see that? Sine and sine is common. The odd one out is cos. So if you want to, you can go straight. Let u equal to sine. The derivative of sine is cos. It will cancel. But let's just write it neatly first so we don't make any mistakes. So what we have there is k to the power 11 and 1 minus k squared. If I replace sine with k. Okay. Times the odd one out. What is the odd one out? It's cos. So let's call cos m. Right, so what we can do here is we can multiply k to the power 11 times 1, which is k to the power 11 minus k to the power 11 times k squared. When we are multiplying and the bases are the same, what do? You add the exponents, so that will be 13. So we got all our common terms within brackets. So that will be sine times 1, that will be sine to the power 11 of x over 2. Sine times sine squared again, minus sine to the power 13. So now, type A. You can see that. So now we have, let me just write it down. We got type A. You must be able to recognize type A, B, C, D. It's always here in these examples, whether it's integration by parts sometimes, but here most of the time. Okay. So why am I saying type A? Because type A deals with f of x and the exact derivative of f of x. Like sine and the exact derivative of sine is cos. So you know it's going to cancel it. So what do? We let u equal to, what do we let u equal to? Sine. So that will be sine of x over 2 du over dx. Again, this is all simple now. Derivative of sine is cos x over 2 times the derivative of x over 2 is 1 over 2. Make dx the subject of the formula. So dx will equal to du over half cos x over 2. Substitute. So all I'm doing is replacing sine with u. So in place of sine, there's my u there, what else? I replace dx with du all divided by half cos of x over 2. You can see the exact derivative must cancel. If it does not cancel, you made a mistake. So now, again, don't make a mistake with the fractions. What can we write down now? So you are dividing by 1 over 2. By now, you shouldn't need a calculator for doing all this here. You're dividing by half means you're multiplying by what?
2.
You're multiplying by 2. So finally, integrate with respect to u and then substitute back. So that will be u 11 plus 1, that's 12 over 12. This will be 14 over 14 plus c. Substitute back for u. What was u? U was, what was u? Sine. So that will be sine to the power 12 of x over 2 divided by 12 minus sine to the power 14 x over 2 divided by 14.